All right, so this is the second part of the function ID video where I had the four scenarios about the candle, the letter, the bus, and the car. And we didn't have any context as far as what numbers were, and I just kind of spitballed some numbers and I threw them together to kind of give us a picture of what we were seeing given the scenario. But now this video has the four different functions that we actually should be using. Okay? And so taking a look at these, okay, I'm just going to identify what kind of function these are and then what situations they could be for. So this first one here, 300 divided by x, okay, my first clue is that it's being divided by x. So whenever my variable is in the denominator, that's a great key that that is a rational function, okay. So in a rational function, one of the things that our teachers have always told us ever since the beginning of algebra is that my denominator can never be 0, and that it's called undefined, okay? Meaning that x can't be 0. So, like we plugged in what we had one graph, I believe it was about the bus, okay? In the bus situation, I can't have no people, otherwise why would I rent the bus? I would have to rent the bus if at least one person was going. So, in that scenario, plugging in 0, meaning have no one on the bus, wouldn't make sense. So that's an undefined value. So this equation is about the bus, which is situation C. Okay. So now let's talk about the second one here, 12 minus 0.5x. All right. So this is what we call a linear equation. But I know a lot of you guys are like, what? I've never seen a linear equation like this. Well, let's say I have apples in my right hand and oranges in my left. And I say I have apples and oranges. If I switch the order of apples and oranges, I still have apples and oranges, right? It doesn't matter what order they're in. So if I wrote the equation like this, you might say, oh, I do recognize this. Okay? So even though it's not necessarily in perfect slope-intercept form, if I were to write my equation like this, then you might say, oh, I do see that this is a linear equation, okay? But one thing I need to notice is that it's a negative linear equation, and I remember there was a problem about the candle, where, again, a candle over time, again, gets smaller and smaller and smaller, which means it has a negative slope. So this one was about situation A, which is about the candle, okay? All right, the third one here, which I'll do in blue, 30 plus 20x. Again, just like the one we just did before, okay, if I rewrote it like this, hopefully you would say, oh yeah, this is a linear equation as well. So this is linear. And the other linear equation we were talking about with a positive slope was the cost of sending a letter, okay? And now remember, it's had an initial cost, like it costs a lot of money to send an initial letter. So it's $30 just to send the package, but after you pay the initial $30, it's a smaller amount to send more ounces. Okay? And I believe we're talking in cents here. So this was actually about the letter, so this is situation B. And then by process of elimination, of course, we can say that this one is D. But here's what I need you to notice about this. Okay? Notice how the variable x is in the exponent. It's really small in the picture, but it's an exponential variable, okay? And notice the base here, 0.5. One thing I hope you learned about exponential functions in your previous math classes is that when the base of the exponent is between 0 and 1, that actually means it's a decay. Or the graph will start really big, and then as x approaches infinity, or as x gets to positive numbers, the numbers will get really, really, really small. So, I hope you guys were able to recognize that this is an exponential function, okay? And the exponential function, there were sort of two of them. Remember, the bus is sort of like the car, but remember, the car had an initial value. Exponential functions can actually cross the y-axis. So remember, our dot was on $10,000. But on the bus situation, remember, it wouldn't be on the y-axis because I wouldn't rent a bus if I had no people. But the car cost $10,000, and that's what I bought it for, even though I've never owned it. So I bought it, and at year 0, it was $10,000. So this one is situation D. Okay, in the next video, I'm going to go through these different scenarios, and we will Let's figure out these problems using the formulas now that we've identified which situation belongs where.